Thanks for joining this session. So I want to talk a little bit about some of the things that Stephen already hinted at, and I'm going to give you a few examples of what we do within Amazon as a whole and how Amazon is a customer of AWS, and we're going to have a look at some of the things like fulfillment centers and Amazon Go stores and try to understand that technology. And one of the driving factors of that is really the element of data, machine learning, and that obviously leads to AI. Now, I'm very fortunate that I'm actually tasked to look after our emerging technologies business, which is working with a lot of our AWS customers out there to build cool things like self-driving cars or autonomous vehicles or drones that fly around, or look into biometric voice printing identities that you do, robotic fulfillment, all the way to precision medicine, such as 3D printing medication, for example. But if you look at all these emerging technologies, one thing is very common, which is that we look at data and build computer systems that are much more human-centric. So traditionally, if I wanted to talk to a computer system, I had to have punch cards. Eventually, I had to learn the command line, a certain syntax. Then along came graphical user interfaces. Then along came kind of touch screens. And then along came voice. Stephen already hinted at it earlier, voice. One of the interesting things, an Amazon Echo speaker that you might have sitting in your room, it's very natural nowadays to talk to a computer system. And moving forward, we will just make more and more human-centric applications. Because the more human-centric we are, the less friction we have, and as Stephen mentioned earlier, that will actually allow us to deliver a better customer experience. I would argue there are two kind of moving forces here. The first one, obvious, data, but also the availability of data and computational power at hyperscale, which is really what cloud computing can help deliver, because I can store any kind of data in different formats and start to analyze it in many different ways. And then the other element is the research and development that's being done in the machine learning and artificial intelligence space, right? If I can analyze that data a little bit better and do it in real time in a much more natural manner, I can deliver more human-centric application. Now, I thought it would be good to start this off with taking a few Amazon examples, right? The first one is obvious. If you take something like the Alexa voice service and the Amazon Echo speaker, a lot of AI and machine learning models that went into that to understand voice, to render voice a little bit more naturally. But there's one other interesting aspect here. It's not just the speaker that we program and you use it based on what we program inside that speaker. We build an entire ecosystem around it where any developer out there can now say, well, instead of me building my own kind of voice models and building my own voice speakers, why don't I just integrate against certain ecosystems, such as, for example, the Alexa voice services? So any developer can go out there, create a skill. It's the reason why you can, for example, call an Uber using Alexa, or you can order pizza with Domino's using Alexa. These are developers that have built skills. As a matter of fact, you have, for example, Autogrow here in New Zealand that went ahead and said, we have IntelliGrow, which is a cloud-based solution to control growing operations for farmers. And I said, could we create like the first ever automated growing system? And they went ahead and within a day, they built a little skill that allows you to use your voice to control their farming systems. Really easy to do that. But let's stay for a moment with Amazon. If you think about Amazon as a whole and Amazon.com, you order things online. If you go to an e-commerce platform nowadays, what do you have at the bottom? It says customer who bought this also bought other goods, or here recommended products for you. We introduced this recommendation engine 21 years ago. That's when we first started working on those research papers and kind of building that out. If you think about it, though, nowadays, if you go to an e-commerce website, you expect this. If you open up your Netflix, you expect that you have recommendation around which series you should watch. If you open up Spotify, you have recommendations about which music you should listen to, or the new artists that are coming out. But I wanted to give you a number on how important it is to personalize the experience, on how important it is to be human-centric. Out of the page views or product views that results to sales, 30% of them actually came from recommendations. That's how relevant that is to your business. And overall, as Amazon, we see ourselves as a technology company, not just as a retailer. But if you go to the retail part of the business, we operate fulfillment centers. How do we treat fulfillment centers? Fulfillment centers to us is a huge space full of data. Here's a video of some of those automated fulfillment centers that we have in certain parts of the world. Here you see a fulfillment center specifically in the US. A lot of automation is happening here. And why is that? Because it's all about a customer experience. What are customers interested in when they order things online? They want a fast delivery, they want a broad choice of products, and they want it cost effectively. So how do you address those points? How can I deliver to you fast? Well, if I optimize the way I run my fulfillment center, I can deliver faster to you. We recently announced that in the US and other parts of the world, we're going to have a one-day shipping across for Prime users. But we also, if you look at some of the videos, got ourselves into logistics, into things like robotics. We have robots that help you with the picking, sorting of packages, and even, to a certain extent, packing of those packages within the fulfillment centers. And why do we do that? Because it allows us to improve that customer experience. It also allows us to reduce the amount of footprint that we require within the fulfillment centers, effectively reducing the cost of running those fulfillment centers, cost savings that we can pass on to our end customers and end users, that as such can get products at a more cost-effective rate. And so let's take that fulfillment center example for a moment. You saw some of those robots swerving around there earlier. What you see here is the first iteration of those Kiva robots. Eventually it became the Amazon robotics department. And this picture now here is 7 years old. The newest iterations look a lot slimmer and are more agile. But what's the idea here? The idea here is that instead of someone running around in a fulfillment center with a big trolley going around in the corridors and picking what somebody ordered, we actually bring the shelf to the packing station. And somebody, just an associate, just takes out the goods that you ordered and required. That allows us, obviously, to reduce the picking time. But one thing that might not be so obvious is that it also allows us to reduce the size required within the fulfillment center. Because we can store those shelves very closely together. We don't need wide corridors. And if you look closely into those bins within that shelf, we stack them up, we pack them. Because we know the space constraints, we know which products are being ordered together, so we put them in the same shelves. We know the dimensions, and we can run an optimization algorithm of effectively using that space within that shelf. But now you've got to ask me, how do I do that, right? If I program something like this, I build a database. In that database, I put some information like I have shelves, I have robots, I have products, I have bins, I have the amount of products within the bin. Here's SKU1 and bin 1. And off you go, right? That should work. I can +1, -1, I'm picking or restocking the shelf. Well, the reality is sometimes those things can go wrong, though. An associate suddenly picks out the wrong good, puts it back in the wrong bin. And now your database is inconsistent to what you actually physically have in the shelves. So you tried to optimize something, and now you actually made it worse, because suddenly you have chaos within your fulfillment center. So again, how do you solve that? How about using machine learning? So what we do is when that robot drives into the packing station, we take a picture of it when it drives in, and we take a picture of it when it drives out, and then we compare those both pictures. We run a computer vision model over it, and we actually look at what are the bins that have been picked. Is this the bin that should have been picked? Is it the product that has been removed? Is it the product that has been removed? Actually, we do not identify the specific product. We just look at the quantity that was removed from a certain bin. And it is sufficient for us to make a determination of the right thing was picked or the wrong thing was picked. Move the robot to the side, and somebody manually intervenes and tries to figure out what went wrong. It gave us one additional power here. If you run an activation and a binary map over those small little cells that you just figured out with your computer vision algorithm, you understand the remaining space within that bin. Now you know the space constraints, you know which products are bought together, you know their sizes, and now you can optimally make use of the space that you have within that shelf, effectively reducing the floor space that you require, effectively reducing the cost. And now you can say, well, if I have technologies like that, could I use them in other parts of our businesses? Certain parts of the world, we actually offer what's called Amazon Fresh, which is an online grocery delivery business. So you shop your groceries online. And with groceries, you have one challenge. You have perishable goods, vegetables, fruits, etc. Right? If you go to a market, what's the first thing you do when you get an apple or an orange? You look at it, you touch it, okay, this one's good, I'll take that one. If you order it online, you don't know what you're getting. But if you think about the customer experience, what do we want to do? Do we want to ship perished goods to a customer? No, of course not. That's a poor customer experience. So how do we make sure that whatever we ship to a customer, whatever we deliver to a customer, is fresh strawberries, fresh tomatoes? You know, they're not perished, they're ripe. And how do you do that? Could you hire someone that just goes through all of it and takes out the bad stuff? Yeah, you absolutely could. Although that's cost effective, and the more problematic things with humans, we fatigue pretty quickly. If you do nothing but sorting strawberries all day, your failure rate goes up pretty quickly, very quickly. So we figured, well, how about using computer vision to solve some of that problem? So in some of these facilities, you have some of the the consumables that are coming in, or perishable goods that are coming in, and we put them on these specialized trays. And that specialized tray actually goes underneath a camera. That camera takes a picture of it and then runs a computer vision model over that picture that was just taken. Based on many, many different pictures that we took previously and manually annotated what looks good and what does not look good, we can build a computer vision model now that can accurately determine which strawberries went bad, which ones have perished, or which ones aren't ripe yet, and which ones should be removed. Obviously, we have multiple models for different kind of fruits and vegetables, but the idea here is that you remove the human error rate out of the equation and actually improve your quality of what you send out to your customers. Because you only send those goods that are ripe and are not perished out there yet. And the idea here, which is really important, is it's not because we had computer vision, we said, now let's build this. It was the other way around. And that's the way you want to think about AI and machine learning as a whole. Right? What's the end goal? What's the customer outcome that I'm trying to derive? And what's potentially the technology that brings me there? And computer vision just happened to be the right thing in our fulfillment center and in the Amazon Fresh delivery stations here. But you could go one step further and you say, well, what if I want to build a convenience store? Right? And I want to build a convenience store, and what's the most annoying thing? If I'm in a rush, I jump into a convenience store, I want to get myself a sandwich, right? And then I have to wait in line because it's lunch hour and there are like 10 people in front of me to pay for their sandwich. Wouldn't it be nicer if I could just walk into a store, take off the shelves, whatever I want, and just walk out, and I automatically get charged towards my account and my credit card? And that was really the premise that we set up when we started working on the Amazon Go stores 7 years ago. So the idea here is you walk in, you just once need to scan a QR code from your phone. You walk in, you take off whatever you want from the shelves, put it straight in your pocket, in your backpack, doesn't really matter. And you walk out and we automatically charge your Amazon account and the associated payment method. Now you might wonder, well, how did we achieve that? So if you ever happen to go into one of those Amazon Go stores, currently they're only available in the US, but we keep rolling them out to further locations, look up into the ceiling. And what you see there in the ceiling is lots and lots of cameras hanging around. And what are those cameras used for? Well, we actually run computer vision to understand how you navigate within that shop. We have cameras hanging on the shelves. We merge that with sensor fusion technology, so there are sensors in the shelves. All of that information, if you combine it together, you can build a machine learning model that understands what you do within that environment, within that Amazon Go store, what you take off the shelves, what you might have passed to your friend, or what have you might put back into the shelves so that we don't charge you for what you didn't buy. And now you might be interested, how would that look like for a back-end system? How does a computer vision model like that look like? Well, if you take all these cameras and you put them together, then you end up with something like this. What you see at the top here is actually one of our first Amazon Go stores during rush hour, during lunch hour. You can see how many people are swerving around there. These cameras are nicely identifying who's that individual, and by the way, we don't identify the individual, it's just an identifier that is taking something off the shelf, but we can track that behavior. Now, other cameras then can look at the models of, well, what are you trying to grab? At the bottom, you see, for example, training examples where two people try to grab the same product. Who are you going to charge? Right? Some very interesting, exceptional use cases that you need to build into your machine learning model. And obviously, it took a lot of video material to kind of train that. But the other thing about machine learning, which is quite interesting, is, well, you need data to train a model. Right? If you have enough data, you can get a good functioning model that gives you a good enough accuracy. Right? And the accuracy needs to be really, really high in that Amazon Go store. If we charge you for the wrong product, that's a very bad experience, right? But how do you get a lot of that data? Well, what you see here on the left side might look to you like a video, but it is actually a 3D simulation of that Amazon Go store. So you create a virtual world where you simulate a lot of the behavior. And that's how you start off training your first computer vision model before you build out the physical shop, and of course, continue to train your machine learning models over time. Now, if you think about this, I talked a lot about the customer experience and how we work backwards towards the technology, but there's one common thing, which is really machine learning and data has helped us refine these models, has helped us to build a better customer experience. And now our mission at AWS is to say we had lots of learnings within Amazon, lots of expertise there. How can we take that technology, those machine learning capabilities, and democratize them, put them out into anyone's hand out there if they're using AWS? And that's really that vision when we built the AWS platform and when we build that comprehensive data analytics, AI, and machine learning portfolio. Foundational services that allow you to build massive data lakes on top of AWS, streaming data and resources from your IT sensor data, from your POS systems, from your social media, from your custom apps, from your website. Doesn't really matter. You bring them into a data lake. You can move data in and out easily, effectively, from your premise, from your office, from different places, easily and effectively using services. And then you start to decouple compute and storage from that analytics pipeline, because you start off by just storing data first in a data lake somewhere. And only when you actually require information, when you want to run a report, when you want to make a prediction, when you want to train a machine learning model, then you take some of those analytics or machine learning services to query information on top of your data lake. And that's really how you want to go about data. Collect everything. Storage costs are very low. You don't really need to worry about them anymore. Store many different things. Right? Don't just think about, oh, I need some sensor data and some POS system data. Good, store that. But how about image and video material? As I've just shown you, those are new data sources. Previously, a video, all you could do is watch. Now you run a computer vision model over it, and you get a lot more information out of it. I'm going to give you a few more examples from our customers in a bit. As a matter of fact, you take, for example, Fonterra out here in New Zealand. They went ahead and said, you know, we get these 900,000 sensors all over the place, and I want to get more information out of it. They went ahead and said, you know, AWS with SAP together, can you help me build an analytics lab on top of AWS? Get that sensor data in, all right? And then try to use that sensor data to understand how can we predict flavor profiles for new products, for example. And by doing that in a cloud environment, they gain speed, agility, right? They brought the analytics lab that they previously built somewhere else down from insights that took them months to achieve down to hours. That is a fundamental game changer, right? Because you can get insights quicker, you can experiment quicker. The more you can experiment, the faster you can innovate. And if you take the machine learning component, we kind of see it threefold, right? How can we put machine learning AI in the hands of anyone out there? And we kind of decided, let's take a three-layered approach, right? Because not everybody has the same capabilities around data science and machine learning. So the top layer is really to say, fully managed machine learning AI services. Services that we train for you, that we continuously improve for you, and that you can just use and integrate into your application using API calls. API calls, a web service, right? That's why AWS is called Amazon Web Services. Everything is an API call away. So you want a computer vision model, you want a facial recognition technology, you want an object detection technology, you want to have the ability to extract information from a document, or in language, transcribe information, use natural language processing, do sentiment analysis on the things that have been tweeted, posted, or talked about, or build conversational interfaces such as chatbot functionalities. All fully managed services, building blocks that I can now take and integrate nicely into my application. Last year, we released something called Amazon Personalized and Amazon Forecast, which are our recommendation and personalization engine services and forecasting services. This is the same technology that Amazon.com is using. So you can get access to the same technology that one of the largest retail and tech companies out there is using by just making an API call. And that is really democratizing that space, right? You don't need to worry about building that anymore from scratch. Just bring in your data, you forecast your own kind of, with your own kind of data, you make your own recommendation, even in real time if you want to, without the necessary need to have any machine learning expertise. Now, in certain scenarios, though, you say, okay, I do have data scientists that have more specific needs. Thank you for the top services. They help me with certain problems within my business, but sometimes I want to go a little bit more granular. And that's really where we want to help you again by saying, how can we make it easier for anyone out there to build, train, and deploy machine learning models effectively? You want to build your custom machine learning model. Well, that's where things like Amazon SageMaker on the AWS platform would come in, for example. So you can build machine learning models with algorithms. Who's going to write those algorithms? Well, you can write your own algorithms. But we said that's not good enough. A lot of people don't know how to build good machine learning algorithms, or they just got started. So how can we kickstart that quicker? And so we provide you with inbuilt machine learning algorithms. And when I say with we, I mean the broader spectrum, not just AWS. There's an entire marketplace where any of our partners provides you with machine learning algorithms. So all you need to do is you bring your data sets in, you train them on the machine learning algorithms where you don't need to write a single line of code. Then you train it and you say, optimize the hyperparameters for me. We'll automatically determine what's the right kind of hyperparameter to get the best accurate model. When you're done with it, you say, deploy it for me, and you get an HTTPS endpoint, an API endpoint, where you can make a call against that model that you just trained. Of course, there's versioning. Of course, there's A/B testing and rollout, many different capabilities. But the key point here is I don't need to know about the algorithm, and I don't really know how or need to know how to train it. And more importantly, as I train it, you only pay for the training seconds that you use, which is obviously the cloud computing benefit that we get out of it. So what would that mean specifically? Let's take an example. What if I say I have lots of picture or video material, and I'd like to classify images. I'd like to detect objects, for example. Well, if you take an inbuilt algorithms like this, we have an object detection algorithm, all you need to do is take a few hundred or 1,000 pictures, no matter how many you want to take, and say, here's a car, here's a car, here's a car, or here's my clicker, right? Here's my clicker, here's my clicker, and off you go, and you feed it to that inbuilt algorithm within SageMaker, and out comes a model that can identify that clicker easily and effectively and draw a bounding box around it. You didn't need to know how convolutional neural networks works. You didn't need to know how to train that model. You didn't really need to figure all of that out. You just brought the data, which is the pictures, and you set what you're looking for, and off you go, and you got yourself an object detection model. That's the power of an inbuilt algorithm. Now, you're going to say, that's all nice and good. OK, I can classify my images, so what's that good for? Let's take an example. Always work backwards from the customer experience. There's a company called Car Sales in Australia. I think it's also famous over here. It's obviously an online platform, as the name indicates, where you can list and sell vehicles, specifically cars, but they extended it, I think, to motorcycles or even motorboats that you can list online. They went ahead and they said, you know, could we create a better customer experience on the online platform? Wouldn't it be nice if I could compare cars? And I say, for example, I look for a car with a big trunk. Wouldn't it be nice, or big boot, or whatever you call it over here? English is not my first language, and the words are different between Australia, New Zealand, and America. So wouldn't it be nice to kind of compare 4 different models that I just selected? All right, compare the trunk, look at the size, is that what I want? Now, that's a good customer experience, right? Work from that customer experience backwards. Now, the problem is it's self-listed. So if I want to sell my car, take my own pictures, I'll list it on carsales.com. So how do I know if I have trunk pictures, right? How can I encourage people to take pictures of a trunk or other parts that people are interested in? That's an image classification problem. So they went ahead and said, we build an image classifier, and every picture that's getting uploaded against the platform, we can identify, is the frontal shot of the car, is the side part of the car, is it the dashboard, is it the trunk, etc. And by classifying that, they can now then create a nice interface where you can compare those pictures. And then you can take it one step further, and you can say, if somebody creates a listing of their vehicle on the platform, and they didn't upload a trunk picture, for example, right, they can send them an email and say, you know what, actually, your probability to sell your car goes up by so many percent if you put up that picture. You increased the customer experience, or improved the customer experience for the seller as much as for the buyer, just by using an image classifier in between. So it's a tool that you can use as such. And you can obviously drive it further. A company called Too Simple, which is using AWS as a platform to build object or computer vision models for assisted driving or autonomous vehicles. What you see here is actually a car that's driving to the streets of Beijing. Now, this is not a self-driving vehicle. This was a test drive that they did to collect information and test their computer vision model. But if you look very closely, it draws borders around the cars and the people and the tricycles that are going around. And if you look closely and you can read the Chinese characters, it even identifies the brand and the model of the vehicle. And right in front of us there, for example, we have a Volkswagen that is driving in front of us. Now, I'm not saying object detection is sufficient to build a self-driving car, but these are the baselines of what we can use to achieve a certain outcome. Computer vision is not something to fear. It's something that's readily available for you to use and very useful in many different domains. I talked a lot about computer vision, but the same applies, obviously, for many other machine learning models or AI models, if you will, as such. And so, in closing, I want to leave you with a few things. First and foremost, I think it's really important that you experiment. Cloud computing gives you those abilities where you say, I can quickly try something out. I have new capabilities at hand with a click of a button that I can use. I can try something out. A day later, I decide it wasn't good enough. You shut it down. It might just have cost you a few dollars, or might even have fallen under the free tier and cost you nothing. That's a fundamental game changer to the traditional model of saying, okay, let's buy all this hardware, let's figure all this software out, let's buy those licenses and figure out how is that going to go for the next year. It's a lot harder to decide for a project than say, let's go ahead, if you have all that capital expenditure. Cloud computing, no matter if it's AWS or someone else out there, but I would recommend AWS, of course, allows you to do all of that. Those capabilities that are continuously improving, right? And then the other thing, which is really important, work backwards from outcomes and then figure out the technology along the way, right? Sometimes I go and talk to customers and they say, I need AI. I say, what for? Well, because, AI. That's not the right way to do it, right? Think about what are you trying to achieve. I'm pretty certain some machine learning will be along the way, right? But work backwards from those outcomes. And then look at the platform that gives you all those capabilities. And our mission remains, has been, and continues to remain, to democratize a lot of this space. And especially when we talk about data analytics or AI and machine learning, we want to democratize those capabilities in many different ways of saying, giving you the capabilities if you don't have them right now, but also continuously lowering the cost of doing so, where it becomes a no-brainer to store data and analyze them because it's just so cost-effective. If you're interested in any of that, got a booth out there. I'll be around at the conference the entire day, so I'd love to hear from you what would be of interest. Thank you very much for your attention. Oh, questions. Perfect. I love questions.
Fantastic. So, hello.
Hey.
Awesome. So the question is, are there any plans to bring an AWS data center to New Zealand? If not, what is the biggest thing preventing this?
Yeah, so it's a great question. So if you think about the overall regional deployments that we do, it is a lot driven by customer kind of feedback and a different kind of business models that we run across. So if you look into the initial AWS model that started off in the US, we brought them out, the Sydney region launched a bunch of years ago. A lot is driven to kind of the utilization of the platform to things like, what's latency sensitivity, what application can we kind of run. And of course, we take a lot of that into account and continue to invest. As you see, we just announced again 3 new regions across, and New Zealand is certainly, our New Zealand customers certainly want to listen to you. One thing that I would say, though, which is, I think, more important, is to kind of always look into what can I enable? What is the reality of what I require? Is it absolutely required for me to be in a certain area to achieve a certain outcome, to deliver a certain application? More often than not, there are lots of services in different places available that can help me deliver that.
Brilliant. Thanks so much.
All right, thank you.